Welcome everyone to a Dolphin Communication Project Dolphin Lesson. Today we are going to discuss sounds in the sea, listening to learn. And we are lucky enough to be joined by Dr. Katie McHugh. She is with the Sarasota Dolphin Research Program in Florida. And like some people at DCP, she actually began her work with that research program as an intern. So for students listening, volunteer where you can, intern where you can, because you truly never know where that opportunity is going to take you. For our live listeners, reminder to submit your questions to the chat, and we will get to those questions at the end. And with that, I will pass it over to Dr. Katie.
Thank you. Let me get my screen going here. All righty. All right, are we good to see slides now?
Perfect.
All right, excellent. Well, thank you guys very much for having me. As Kel said, my name is Katie McHugh, and I work as part of the Chicago Zoological Society's Sarasota Dolphin Research Program. For those of you who are not familiar with us, we are the world's longest running study of a wild dolphin population. We celebrated our 50th anniversary back in the fall of 2020. And I have not been part of this program that whole time, but I did start in 2000, so just over 20 years ago, as a college intern and came back as a graduate student, and then now I'm a staff scientist with the program. And the work and the information I'm going to present today is really that of our wide network of collaborators that focus on studying dolphin communication and acoustics in the Bay. This presentation specifically was put together with two of my collaborators from both Mote and the SDRP, Kim Bassos-Hull, who is a senior biologist at Mote, as well as a research associate with the SDRP, and Dana Henderson, who is a school programs coordinator at Mote Marine Laboratory, and who is turning some of our work around sound in the sea and using acoustics to study marine animals into an actual curriculum for 3rd to 8th grade levels. And so I'll have a little bit of info on that later. If you or someone you know would like to get access to that, she's happy to share it with folks. All right, so what am I going to talk about today? The focus is really going to be on introducing everyone to sound, sound vocabulary and technologies, how some of our research on marine animal sounds and anthropogenic noise impacts, and then sort of two of the networks of different types of acoustic technology that we use to study marine animals over larger scales. So one of these is an underwater listening network that we have, which we call the Sarasola Bay Listening Network. The other is an active acoustic network that tracks tagged animals using acoustic tags that have particular signatures, and that's our Sarasota Coast Acoustic Network. And then, like I said, I'll put in a little plug for the educational activities that should be coming and available on the web soon that are connected to all of these types of things. So to get us all on the same page, first, just what is sound? Okay, so sound is energy created by a vibrating object, and it travels as a wave through a medium. So for example, it might travel through a liquid such as water, a solid like the seafloor, or a gas such as air. And for underwater animals like the dolphins that we study, it's really important to note that sound travels much faster, about 4.3 times faster underwater than in air. And it also can travel much farther and give you information when you might not be able to sort of see as far underwater. So sound is really important for marine animals, especially the marine mammals that we study. How do we measure sound? Well, there are two key metrics that you should think about or know about. We're going to talk about sound. These both have to do with measuring those sound waves that propagate through the water in our case. So the first is amplitude. This is the loudness or intensity of a sound, and it corresponds to the height of the sound wave. It's measured in decibels. The higher the wave, the louder or more intense the sound. The second is frequency. This is similar to pitch or tone of a sound. And this is measured as the number of waves that pass a fixed place in a given amount of time. The measure is called hertz. And in general, A low frequency sound has fewer waves passing in a given period of time. A higher pitch sound has more waves passing in a given period of time, or a shorter wavelength. How do we actually work with these sounds as researchers who are trying to study, especially animal vocalizations? Well, we typically are using a visual representation of sound called a spectrogram. This shows all of the frequencies that are present in a sound on the vertical axis, the y-axis, and then time on the horizontal axis or x-axis. And the intensity of color is corresponding to the amplitude or the loudness of the sound at that frequency over time. How do we access and actually listen to these sounds? Well, we use basically underwater microphones called hydrophones, and they work just like a microphone to detect and help us record sound under the water. All right, so to get us thinking about what kinds of sounds we actually hear down there, I'm going to give you all a minute to sit and think. We're going to listen to a sound, and then you can either like show me with a finger or type into chat or just think quietly to yourself whether you think this is going to be a fish, a shark, a ray, a shrimp, or a dolphin. So that's 1 through 5. Here's our first sound. I'll play it twice. Everybody hear that? It's kind of quiet. Here we go, one more time. All right, what do we think? This first one is actually a toadfish. All right, number 2, let's go on. Here, this one's also a little bit quiet, so let's see if you can hear. Oh, louder. All right. Got some crunching and then some sort of popping sounds in the background. All right, any guesses? Yeah, I see someone with a 4. So this one's a little tricky. Sorry, it's actually 2 of them. So this is a ray. The crunching sound you hear is the ray crunching down on a mollusk as it's feeding. And then the popping sound in the background are snapping shrimp that are all throughout the environment, especially in the coastal environment. We hear them a lot. All right, and then last but not least, here we go. Yeah, sorry, I hit the button instead of playing it again, but yes, that one is a dolphin. For those of you who are expecting marine mammals, that is your typical dolphin whistle. Great job. All right, so these are the kinds of things we can hear, but why are these animals making all of these sounds? Well, it's any of the reasons that you might expect anyone to make a sound, right? Just like with people, they use sound to communicate with one another. They can also use sound. You might know that dolphins in particular and some other marine mammals are able to use sound to navigate. So they can use sound to actually sense where objects are in their environment. Some animals use sound in feeding. So dolphins can use that same type of sound emitted from their bodies to bounce off of objects and look to find food and catch food. Or they might make mechanical sounds while eating, like those rays that we can hear and know when a ray is feeding in the benthic environment. They also use sounds to attract each other, so for mating and courtship and other reasons. So there's lots of reasons why animals make sound. And underwater, sound is a great way of being able to keep in touch and be able to find each other because of how far and fast sound travels. As researchers, studying sound and studying dolphin communication is really a team effort. And so I will mention throughout this presentation a number of collaborations that we have that have helped us learn about dolphin sounds and other sounds over the years. In particular, when it comes to dolphin communication, we work very closely with folks from Woods Hole Oceanographic Institution and the University of St. Andrews. And we study dolphin sounds and dolphin communication using a variety of different techniques. So one pretty basic thing, and how I'm involved in this project most of the time, is getting on a boat, following dolphins around, and putting a hydrophone in the water, or possibly putting one of these new digital acoustic tags that have a hydrophone actually built on board and stick to the animals with suction cups, and then following the animals around in their natural environment, watching who they're interacting with and what they're doing while we have the recordings to see what sorts of sounds are being made in different contexts. Another way that we can study individual sounds is by actually sticking a hydrophone here with a suction cup right to the dolphin's forehead. This is a special organ on a dolphin called the melon. And inside of their forehead, this melon will actually direct and focus and localize sound. So when a dolphin is making a whistle or echolocating, it's actually coming out of this melon in their forehead. So we can stick a hydrophone right to an individual dolphin if we have our hands on it for a health assessment or something, and actually record all the sounds that it specifically is making. It's helped us understand how individually distinctive different whistles that dolphins might make are. We also are able to do things called playback experiments, where either while we have an animal temporarily in hand or to an animal that's free swimming out in the environment, we can play sounds back to them and look at how they respond to them to understand what kinds of information they're getting out of the sounds and what sorts of cues they're using to understand maybe if this is a particular individual or a particular context from their vocalizations. All right, so let's listen to some more dolphin sounds. So probably the most famous dolphin sound that you guys might know are their whistles. That's what I played an example of before. But it turns out one of the things we first discovered in Sarasota Bay with our collaborators is that dolphins actually have individually distinctive whistles. We call them signature whistles, and they function pretty much like names. They can be used to reference a particular individual in a conversation, used to make sorry, not conversation, use a particular individual in a group. They can also be used to maintain contact when animals are not right next to each other or when groups are joining or splitting. So dolphins have really, really active social lives. They're not always right next to the individuals that they might be, closest in relationship to, but they want to know where they are at different times. Those are some of the ways that they use these whistles. This particular example here, so this is a spectrogram, and you'll see a whole bunch of these throughout the presentation. We've got that frequency on the vertical axis, time on the x-axis, and the brighter the color, the louder the sound. This is an example of an exchange of signature whistles between a mom and a calf that was recorded while they were temporarily being restrained for a health exam. So here you'll hear the two different whistles and hear them call back and forth. All right, so those two whistles are pretty different. The one's got that sort of triple sort of sweep, sort of weet, 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 and then the second one, a down sweep. Here's 4 more examples, and we'll see if you guys can match what you think, which one matches which picture. So I'm gonna play all 4 of them, and then just think to yourselves or write it down or put in chat which picture you think goes with each sound. All right, so here's the first one. I'll play it one more time. Oops. Oh, no. Hold on. Never mind. You didn't see that. All right. There's the first one. Second one. Third. And lastly. All right. So you can kind of hear the differences. Can you match them to the pictures, you think? So here's the correct answer for those who haven't yet shown me what they think. All right, the first one here is number 4. Let's see if you can hear all those different whistles coming right one after another. The second one is going to be picture 3. It goes higher pitch, then down and back up again. Third one is actually that first whistle. You hear it goes twee, twee, and there's like this messy wah in the middle. That's all this action you can see on the spectrogram here. And then the last one is this nice tweet, 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 and that's picture number 2. So you can see that there's quite a bit of variation in what these whistles sound like. And with our long-term collaborators over decades and decades, we now have a database of almost 270, so 269 different dolphin names. And this picture here, each of these little sections is a different one of these signature whistles from a dolphin in Sarasota Bay. So we normally tell dolphins apart in our research by taking pictures of them and looking at differences in their dorsal fins. But we can also tell them apart by collecting recordings of their whistles and then comparing them to a long-term catalog of their sounds. And these whistles are most likely how the dolphins actually tell each other apart when they are swimming around underwater. All right, so what are some other dolphin sounds? Next is echolocation. I've already mentioned this is a a type of sound they can use for both navigation and feeding. It's characterized by these really broad bands. So this energy is all the way across the frequency spectrum, but really short duration, what we call clicks or buzzes if they're close together. And this is what this will sound like as they might be echolocating on an object. Those clicks are going to get closer and closer together into what we call a buzz. This particular one was recorded from an adult male from a DTAG that was stuck onto him, and he was swimming around doing his thing out in Sarasota Bay. All right, so that's echolocation. This next one is probably going to be, oh, hold on, not loud yet. I'm going to go to this video. So echolocation, that's an example of what it sounds like. I'm going to quickly show you how they use it in context when they're feeding with the video that I couldn't embed. But here, this video is going to show you two dolphins, a mom and an older calf. We're recording their behavior, in this case with an overhead view from a drone, and both of the animals are wearing a little tag that's recording the sounds they're making and their movements, so we can look at how the sound and their behavior are connected. So here you're going to hear them echolocate and then also watch them as they're trying to catch a couple of fish. So you hear those buzzes get closer together. Then you'll see them whip around, and that's them trying to hit a fish with their flukes, with their tail. That's how loud a breath sounds on this tag. They didn't catch the first fish, but here, that time they made contact. You saw the fish hopefully go flying through the air over here, and they're going to go over and get themselves a snack. So this is kind of what that looks like when an animal is actually echolocating and going about its business trying to catch a fish. Back to my slides now. Okay, so that's echolocation in context with a couple of the tools that we use to study it. Another broadband kind of sound that dolphins make, usually in really high energy sort of social interactions, are called burst pulse sounds. So this one is the one that's going to be really loud for everybody. So turn your volume down, or I don't know, hopefully I don't blast you out here. But this one sounds pretty awesome. It's also recorded from a DTAG from the same adult male that last echolocation sequence before the video was recorded on. All right. So that one's pretty exciting. I'm not really sure what he's saying. All I know is that it is the kind of thing that they do. In particular, this male is part of an alliance, and this particular exchange was recorded, I believe, as they were approaching and just encountering an adult female that they were potentially interested in mating with. All right, so when I mentioned these D tags, this is what they look like up close. This is the tag that we can stick to the back of the dolphin. It has two hydrophones in it, and it also has an accelerometer and magnetometer, so it can record depth and temperature and all of the different pitch and roll and heading of the dolphin as it's turning around. And so some of these non-whistle sounds that we've recorded have been more in the context of recording free-ranging animals. So our echolocation or burst pulses. Another type here called quacks are also often used in sort of social interactions, sometimes in an aggressive nature. And this is one I just wanted to play because it's so different from what you might think of as a dolphin sound, but it is one. I don't know why it's not playing. 1 second. There we go. So you can see why it's called a quack, but it very much sounds much more like a bird, but that is actually a dolphin engaging in, again, social interactions, particularly with other adult males. So another thing that these sounds let us record is not just, or sorry, these tags let us record is not just the sounds the dolphins are making, but also any sounds the dolphins are hearing. And so one really important thing that we know and we've learned over many years of studying these animals is that human noise in the marine environment, things like boat engines, can really provide a problem for animals trying to communicate using sound. It can mask whistles and it can interfere with their communication. So this is a simulation of what would happen if a boat were to go by a pair of dolphins that are whistling back and forth. So they'll see bouts of signature whistles and then how those signature whistles get masked as boat noise comes into an area. There it goes away again. So, it's a very temporary thing that can happen, but in a place where there's lots of boat traffic, each of those boat passes is going to take a few seconds where the animals won't be able to hear each other. And so one of the things we like to do when we're talking with or working with boaters is just encourage them to slow down or to give a bit more space when they're traveling by groups of animals so that the engine noise won't provide such a problem to them. So we aren't only interested in the sounds that the dolphins are making. Like I said, human sounds are important, but also the dolphins are really interested in sounds that other animals are making in their environment as well. And we know that dolphins can eat a wide variety of fish. One of the things we've learned is that they select for the kinds of fish that make sound, fish that are called soniferous. So the details of this table aren't important, but these are two examples of fish that are some of the top choice prey items for dolphins in Sarasota Bay. The green star is a toadfish and the red star is a spotted sea trout. And we find that these types of fish are found more frequently in dolphin stomachs when we've looked at what they've been eating after they were covered by a stranding network, then they are found in the environment in our prey sampling surveys. So they're more likely to be eaten relative to how many of them are out in the environment, which means we think the dolphins are using their sounds to actually find and select for them. So here's that toadfish. You should remember from way back in like slide 3. And that's what he sounds like. And here's a spotted sea trout. So, to us, it might not sound like a whole lot, but to a dolphin, that sounds like dinner. And they're going to head off after that sound that they'll see, and then maybe use their echolocation to actually hone in and catch their prey at the end. The other thing to think about with those sounds is how low frequency they are and how quiet they are relative to some of the other sounds I've played, which means that things like the boat noise I just mentioned can really have an impact, not just on dolphins hearing each other, but dolphins also hearing the kinds of sounds that they need, like these fish, to go and find their food. All right, so here's just for fun, some other types of animals that make sounds. Again, these are spectrograms of what the sounds look like. Up here on the top, our first one is going to be a silver perch. So this is another fish. Sounds like just like hammering or something. Next, we've got a hardhead catfish. Third, a sand sea trout. Oops, let me see if I can get this over here. Here we go. That sounds just like a little grunting. Snapping shrimp. So here's going to be the snapping shrimp without a ray in the background. So it's that popcorn-like sound you can hear. Then we've got a black drum. And then last but not least, lest you think that dolphins are the only marine mammals we care about in Sarasota Bay, it's not true. This last one over here is actually a manatee. Check this one out. Play it one more time. Their little squeaks are definitely not necessarily what you might think would come out of a big animal that size, but that's sure what some of their sounds sound like. Oops. All righty. So there's a little bit about what some of the sounds that animals make and some of the ways we study the sounds coming from individual animals. But what we're doing now as a broader part of our research is actually trying to study sound over our whole sort of region of our study area. And so we monitor what we call the soundscape, or that's underwater sound, all in and around Sarasota Bay through a system that we're calling the Sarasola Bay Listening Network. It is a series of these little small solar powered, what we call PALs, or passive acoustic listening stations. And they're placed all around Sarasota Bay, from down near Venice up to Anna Maria Island. These two stars are our newest two stations, which are actually at Anna Maria Elementary School and over at New College of Florida. So we have a couple actually at some schools now where we're hoping to do some work with students, being able to actually use the sounds that are recorded from right behind their backyards there. And these stations provide a way to remotely monitor some aspects of the environment, things that we can hear with sound. For example, we're able to see, this is decibels or loudness in a couple of different frequency bands as a red tide moved into an area. And it's a little bit subtle. You'll hear how it's not really that subtle in a moment, but the overall sound levels decrease pretty quickly as red tide comes into the study area. But we can use these for broader scale dolphin detection, monitoring of anthropogenic sound, as well as looking at acoustic ecology. So one thing that we're working on and hoping to do more in the future is doing actual automatic detection of signature whistles of specific dolphins from these stations. This is an example of 3 animals. They actually all happen to be part of the same family, if you will. This is the mother, an older daughter, and then this is a younger sibling, all of whose whistles were detected over and over and over again at one of our PALS listening stations up in the northern part of our study area. And we worked with a student who was able to use like sophisticated, I guess like complicated, but really powerful machine learning tools to be able to detect those specific whistles in and amongst all the sounds that are heard from our network. We also were able to tell when boats are coming by. Their sounds are pretty obvious. You know, we can tell if a hydrophone is out all the time monitoring sound, how frequently are boats passing by this location. And obviously there's quite a bit of variation depending on where we might be in our study area. Is a site near a boat channel, or is a site back in the mangroves? They're going to have very different background noise depending on where they're located. And then for acoustic ecology, we're able to look at how the soundscape changes over time. In particular, we've looked at how the soundscape changes after a disturbance from, in this case, a red tide moves into the area. So these 3 panels were recorded all from one of our listening stations up in the northern part of our study area. And they're August 1st and September 1st of 2018, so before and during a red tide. And then nearly 7 months later, after the red tide had, 7 months after the red tide had gone away, you'll be able to hear the differences here. So here's what the sound sounded like before red tide came in. So you can hear dolphin echolocating. You can hear snapping shrimp. And at the bottom there's a little like wah, 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 which is a toadfish. After a tide moved through, it killed a lot of fish, and a lot of dolphins also moved out of the area. The same station 1 month later, this is all we could hear. It sounds silent. It is almost virtually silent. All there is this one toadfish kind of going womp, womp, womp every so often, who didn't get killed and was still around in this area. And then later, 7 months later, we can start to hear things coming back, but it's nothing like it was before. This might be quiet for you, but there's a little bit of snapping shrimp in the background again. We were able to actually quantify or analyze how different these soundscapes were as the red tide moved into the area. So I'm pretty much done with all the stuff I wanted to tell you about dolphins, but I'll take just a minute to share with you a little bit about how this passive acoustic network, what we call our PALS stations, integrates with the second one that we call the Sarasota Coast Acoustic Network. So Our passive detection from our normal hydrophone receivers is able to help us hear anything that makes its own sound. So dolphins, sound producing fish, biological noise, anthropogenic noise. But what about the species that don't just swim around making their own sounds all the time? Well, there's still a way to use sound to study them. And what we do there with some of our collaborators is we have a second network. This is a network of passive receivers for a particular type of tag that can be put on or in a fish that emits a sound. The receiver will pick up that individual ping from that tag as it swims by, and you're able to track the animals that way. So we use these kinds of technologies to study things like sharks and rays and some of the fish that don't make their own sounds. Both in Sarasota Bay, sorry, that was the red spots here on this map are those receivers, and the blue triangles are our other listening stations. But also in broader networks across the whole Gulf of Mexico, up and down the coast of Florida. Many of these species travel much farther than one research or study area. And so these networks of tag receivers let us actually track animals as they move between areas. The code that's on the tag let the researcher who's working in a particular area know which animals swim by their receiver. If it's a tag code that's not one of yours, there's a central place where all those researchers can come together and share information on which tags went by their sites. So it allows tracking of animals over a much broader area. How it works, basically, a shark has a tag in it, let's say, a particular type of receiver might be able to detect that shark from up to, say, 500 meters away. As it swims by the receiver, it's going to say ping, 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 ping. Oop. This ID passed by at this time on this date and it got 3 meters away. And then bing, bing, bing by the next one. Okay, the same ID went by this station on this date at this time and was 6 meters away. So you can track a collection of those detections from those tags over time and also work to track those animals. In our study area, Kim Bastos-Hull and her collaborators in the SCAN network have followed and tagged a number of different species. Their focus was initially spotted eagle rays, but there are also folks working on snook, even lightning whelks. So you can even tag and track a mollusk, you can, with sound. Various species of sharks and also devil rays. And for spotted eagle rays, they've been able to use this acoustic tagging to look at short and long-term movement patterns of an endangered ray that we didn't know much about, sort of what spaces it was using prior to using these techniques. And the studies really worked with students as well throughout the project through some collaborations with Mote Education and helping with a lot of the different aspects of it. Last year, they were able to publish the sort of collaborative results of looking at migration patterns of eagle rays using these techniques all along Florida's coastlines. This is a little complicated, but I thought it was interesting just to see what these data look like over the long term. So you have one chart over here for the Gulf of Mexico and one for the Atlantic coast of Florida on the bottom. Each line is a different tagged ray. And each color, as you go across its time on the horizontal axis, is a different receiver array where that ray was picked up. So for example, this ray down here was up in the green part, so near Sarasota and Tampa Bays. Then it went down into this white area, which is the Charlotte Harbor area. Eventually it went all the way down. We see some orange, so all the way down into the Florida Keys. So you can see how you're able to actually see where these individuals get picked up over really broad areas. And it really helps to work as part of a network to be able to get this kind of information. All right. And again, with this project, we've worked with students. It's a tagging mollusks. So they actually were able to acoustically tag some of the potential prey items from the rays and then get practice working with these different kinds of technologies, as well as how you analyze these kinds of data. And so we're always interested in thinking about ways that we can get kids involved in thinking about how you might study something in their aquatic backyards, and whether it's a dolphin or a ray or a whelk or a mollusk. All right, so just lastly, my little pitch. So anyone out there who's interested in learning more about these kinds of techniques, or maybe, using some of these data in a formal or informal classroom setting, we have been working with folks from Mote Education to create a series of educational activities that are aligned to standards. They're for grades 3 to 8. There's full lesson plans that'll be freely available and resources that are launching and should be online very soon. And we are actively looking for teachers and informal educators to pilot the program and provide some feedback. So we should be posting it soon to this section of our website, sarasotadolphin.org/students, or folks can email Miss Dana at mote.org for curriculum access. She's the Mote educator who's handling most of that sharing. And then just big thanks to all of the people and organizations that are involved in trying to do this type of work. It's definitely not something that I do alone, or even that I necessarily lead for our program. It's just something that I'm involved in and really excited about the potential for all these kinds of technologies and techniques to help us learn about animals underwater. And then any questions? I'm happy to sit around and chat as long as folks want.
So much, Dr. Katie. Lots of good information in there. I'm just going to wrap up for a minute and remind folks, if this was your first DCP webinar where you can find the recordings, just head to our website, dolphincommunicationproject.org, and under that education tab, you'll find the webinars and you'll find all of the programs that we've recorded since spring of 2020. This was a dolphin lesson, so I found it interesting, even at my advanced age. But then we also have deep dives that are a bit more involved and a bit more advanced. If you get through all of that and you need more, you can snag episodes of our podcast, The Dolphin Pod, wherever you get your podcasts. And then if you want to join us in the field, we actually have a field program this July. If you're listening live, we only have 2 spaces left. So you can feel free to email us if you have any questions. And then, like Dr. Katie said, it's all a collaboration and takes a lot of work, and it's not one person. So our supporters are a big part of how DCP gets our research and our education programs happening and off the ground. So you can adopt a dolphin, become a member, as I said, join us in the field, all sorts of ways. And of course, stay in touch. So there you can see our social media and our email addresses so that you can ask us questions and check in. So thank you to everyone who listened live, as well as whoever's listening to the recording. Do we have any questions for today while we still have Dr. Katie here? I think I had 2 come in. So I'll hit those up. Dr. Katie, what is the most surprising thing that you have come across on one of the passive recordings?
Oh, I don't know if it was that surprising. It shouldn't have been, given that these are mostly land-based sites, but we had a student one time that just kept saying, I just can't figure out what kind of fish this is. And sent me the recording, and then both myself and Dr. Reisick, as one of our collaborators, are like, I think it's a bird. And it was, it was a bird that was on land, but we could pick it up on the hydrophone underwater. But it took us a minute to just even think that it wasn't something underwater, but we were picking it up with a water microphone. Yeah. So anyway, it shouldn't have been surprising, but it was.
Mm-hmm. And then another question was about how you handle storms. Do you have to go and retrieve your stations? Do you just hope for the best? What happens if a hurricane is coming?
Yeah, that's a great question. So at the moment, for all of the PALs, so our passive acoustic receivers they're all at the moment shore-based. And so they stay in place and we hope for the best. And we haven't had any trouble with them yet, but they're pretty simple, like a solar panel and 1 box, and usually mounted to a pole. So we've been fortunate we haven't lost any equipment to storms that way. For the underwater receivers in the scan network, they do occasionally have trouble finding them after storms, especially if a whole lot of sand or something moves over, they can get buried and be hard to find. But for the most part, the stuff does stay in place through storms, and we just hope we can find it afterwards. And so far, knock on wood, so good. Yeah.
Excellent. Hopefully that good luck continues as we approach June. Everybody in this region starts to be on alert. And we had another question came through. I'm guessing maybe it's because of the question we just asked. Is it a challenge? Does the public interfere with the devices?
Not so far. But that being said, we've only have a couple so far that aren't on like private property. So
Private
we
property.
have the one that went in at the college and the elementary school. I mean, both of those sites have been in for over a month and no one's messed with them yet. We have one that's at like a public park down in the southern part of our study area, but it's kind of like just off the seawall. Like you could reach it if you wanted to, but I mean, there's a sign next to that one that says what it is and what it's for, and what it's recording. And so far we haven't had anyone mess with them, but now I feel like I need to knock on wood again. And
Sorry, man. I was like, should I ask this question? Shouldn't I? But it's good to know that there's also signage. And so if the community does come upon it, then they know what it is. And then hopefully they can seek out more information if it's something that they're interested in.
Yeah, and the same thing actually with the tags. So the suction cup tags that we put on the dolphins, there's a little label on them usually that has a phone number because, you know, I mean, a dolphin can get that off of them if they want to. They just leap and the suction cups come off. And if we don't happen to be right there, then the tag will float around. And so those have ended up on beaches before and people will find them. And so far, everyone's actually called the number when someone besides us has found it. And we've been able to go meet up with them and get them back. So yeah, we've been lucky.
Awesome.
People have been really good about our equipment so far.
Yay for good citizens. Awesome. Well, thank you so much, Dr. Katie. We appreciate your time and all of the information, and we hope everyone has enjoyed listening, and we'll see you all at another Dolphin DCP webinar.
All right.
Bye.